Okay, so another two-part problem here. A patient is to receive 900 milliliters of lactated Ringer solution for a 12-hour infusion starting at 8 o'clock in the morning. At 3 o'clock in the afternoon, which would be 7 hours later, you notice 500 milliliters of solution remaining in the IV bag. So the question, is the infusion progressing too slowly, too quickly, or at the correct rate? And B, if you determine that the infusion is not progressing at the correct rate, what observable drip rate should be used now at 3 p.m. so that the infusion finishes on time at 8 p.m. All right, so in part A, we want to look at the infusion rate. If we were to take 900 milliliters and partition that over a 12-hour period, that would be the same as saying we should have 75 milliliters infused per hour. So for every 1 hour of infusion, 75 milliliters should be used up. So when it's 3 p.m., as we said, that's after 7 hours. So if for every hour 75 milliliters is used up, if we multiply that by 7 for the 7 hours, then 525 milliliters should be infused. That's if this is progressing at the correct rate. So if it should be infused at a rate of 75 milliliters per hour, then what we should see is that 525 milliliters should be gone. So if we take the 900 and subtract 525, then this says that 375 milliliters should remain at 3 p.m. However, we notice that there's actually 500 milliliters of solution remaining, so not enough has been infused into the patient. So since 500 actually remains, so since 500 milliliters remains, this means that the IV is going too slow. There's too much fluid left in the IV bag. There should only be 375 milliliters, but there's actually 500, so there's too much, which means the IV is progressing too slowly. So that's the answer to part A, too slowly. So now we can answer part B, or we can try to answer part B. All right, part B says, if we determine the infusion is not progressing at the correct rate, which we did, what should be the observable drip rate? So let's go on to the next page. So for part B, we have 500 milliliters at 3 p.m. and we want to finish by 8 p.m. So that's 5 more hours. So for our observable drip rate, we wish to infuse the remaining 500 milliliters in a 5-hour period. As we've done with the previous drip rate problems, we're going to break everything down into seconds, and we need to multiply by the IV calibration rate, which I don't think I gave you in the previous problem. I don't. So let's just say, for the sake of argument, that we are working with an IV calibration rate of 15 GTTs per ml. So that's my fault, but that's what we're going to do. So with 15 GTTs per ml, so that's the IV calibration. What you get, once you multiply and divide everything out, is 25 GTTs per minute. Now, we started off, in fact, let me erase that. And let's do this per seconds. So when you multiply this out to determine the unit drip rate, so you have 500 times 15, so this is 7,500 GTTs. And in the denominator, you have 5 times 3,600, which is 18,000 seconds, right? Because everything else gets canceled. Hours gets canceled. Milliliters gets canceled. You have 7,500 GTTs in 18,000 seconds. And if you do the math there, that comes out to be 0.416 GTTs per second. And again, now we have to make this observable. So we could try multiplying by 30. So 0.416 times 30 would give us what? Would give us 12.5 GTTs in 30 seconds. And you can see, of course, that you cannot measure or observe half of a drop. So we try again. And of course, to just get rid of that fraction, if we multiply by 60 instead of by 30, then that's how we come up with our final answer. 25 drops per minute. So this will allow the remaining 500 milliliters to finish infusing at 8 o'clock. So for part A, too slowly, the drip rate or the IV was not progressing at the correct rate. And for part B, we're going to adjust the drip rate to 25 drops per minute so everything finishes on time.